Look up at the night sky. Somewhere beyond the stars you can see, beyond the planets, beyond the Milky Way, beyond almost everything humanity once believed was the entire universe, there is a faint, ghostly glow. To the naked eye, it looks like nothing more than a tiny blur, a soft smudge of light, quiet, distant, almost invisible.
But that little blur is not a star, it is not a cloud, it is not even inside our galaxy. It is Andromeda, a colossal island of stars, gas, dust, black holes, and possibly countless worlds. And every second, it is moving closer. Right now, while you are watching this video, the Andromeda galaxy is racing through space on a long gravitational journey toward the Milky Way. One day, billions of years from now, these two great galaxies may meet in one of the most spectacular events in cosmic history. But before that happens, we need to ask a bigger question. What is Andromeda?
Who first discovered it? What is hidden inside it? And could there be planets, maybe even life, orbiting stars in that distant galaxy?
The Andromeda galaxy, also known as Messier 31 or M31, is the nearest major galaxy to our Milky Way. It sits about 2.5 million light-years away, which means the light reaching our eyes tonight left Andromeda when ancient human ancestors were just beginning to shape stone tools on Earth. Imagine that. When you look at Andromeda, you are not seeing it as it is right now. You are seeing it as it was 2.5 million years ago. You are looking into the ancient past. And for most of human history, nobody knew what that faint glow really was. Long before telescopes, long before rockets, and long before the word galaxy had its modern meaning, people could see Andromeda under dark skies. But the first known written record came from the Persian astronomer Abd al-Rahman al-Sufi, who described it in the year 964 CE as a little cloud or nebulous smear in his book of fixed stars. That description was simple, a little cloud. But hidden inside that little cloud was an entire galaxy. Centuries later, telescopes improved. Astronomers began to examine this mysterious object more closely. It became known as the Andromeda Nebula because many scientists believed it was a glowing cloud of gas inside the Milky Way. At the time, the Milky Way was thought by many to be the whole universe. Everything! Every star, every nebula, every mystery, all contained inside one great cosmic system. But Andromeda was about to destroy that idea forever. In the early 20th century, astronomers debated a huge question. Was Andromeda part of the Milky Way, or was it an island universe of its own? Then Edwin Hubble looked at Andromeda and found Cepheid variable stars, stars whose brightness changes in a predictable way. Using Henrietta Leavitt's work on Cepheids as distance markers, Hubble concluded that Andromeda was far outside the boundaries of the Milky Way. And with that, the universe became much larger. The Milky Way was no longer everything. It was just one galaxy among many. Andromeda changed the human view of existence. It showed us that the universe was not a small sea of stars. It was an ocean of galaxies. And inside Andromeda, that ocean becomes almost impossible to imagine. Andromeda contains roughly 1 trillion stars. That is more stars than the Milky Way is usually estimated to contain. NASA's Hubble observations have resolved more than 100 million stars and thousands of star clusters in just a portion of Andromeda's disk. Think about 1 trillion stars, not 1 trillion rocks, not 1 trillion grains of sand, 1 trillion suns. Some are old and red, some are young and blue, some are dying, some are being born. Some may be orbited by planets, some may have moons, some may have oceans, and some may shine over worlds we will never see. Andromeda is a spiral galaxy like the Milky Way. It has a bright central bulge filled with older stars. It has dark dust lanes stretching across its disk like cosmic scars. It has spiral arms where young stars burn blue and bright. It has star clusters, gas clouds, and regions where gravity pulls material together until new stars ignite. But Andromeda is not alone. Around it are smaller satellite galaxies, including M32 and M110, dwarf galaxies caught in its gravitational influence. And this tells us something important. Andromeda is not just a galaxy, it is a system, a kingdom of stars, a gravitational empire. At its heart lies something even darker, a supermassive black hole. Like the Milky Way, Andromeda has a massive object at its center. Around it, stars crowd together in a bright, dense nucleus. The closer we look, the more strange this center becomes. The core of Andromeda appears to have a complicated structure, shaped by ancient collisions, gravitational interactions, and the violent history of galactic evolution. Because Andromeda is not peaceful. It only looks peaceful because it is far away. In reality, it is a galaxy built by gravity, collision, and time. Over billions of years, Andromeda has likely swallowed smaller galaxies, absorbing their stars into its own great disk and halo. Every stream of stars around it is like a fossil, evidence of ancient galaxies that came too close and were torn apart. This is how galaxies grow, not gently, not quietly, but by merging, pulling, stripping, and consuming. Andromeda is beautiful, but it is also violent, a shining spiral made from countless ancient disasters. But the biggest mystery is not just what is inside Andromeda, it is whether Andromeda has planets. And the answer is fascinating, almost certainly yes. If Andromeda has roughly 1 trillion stars and planets are common around stars, then it would be strange if Andromeda did not contain planets. There may be billions, maybe even hundreds of billions of planets inside Andromeda. Rocky planets, gas giants, frozen worlds, lava worlds, planets orbiting red dwarfs, planets circling stars like the Sun, maybe planets with rings larger than Saturn's, maybe moons with underground oceans. Maybe worlds where the sky is filled with the glow of Andromeda's crowded stars. But here is the catch. We have not clearly confirmed individual planets in Andromeda the same way we confirm exoplanets inside the Milky Way. Why? Because Andromeda is too far away. Detecting planets in our own galaxy is already difficult. We usually find them by watching a star dim slightly as a planet passes in front of it, or by measuring tiny gravitational wobbles caused by orbiting planets. But Andromeda is 2.5 million light-years away. Its stars are packed together from our point of view. Most of them blur into a single glow. Finding a planet there is like trying to detect a dust speck passing in front of a candle on another continent. Still, there is one intriguing candidate. A possible planet called PA99N2b has been proposed from a microlensing event toward Andromeda. Microlensing happens when gravity itself acts like a lens. If a star passes in front of a more distant star, its gravity can bend and magnify the background light. If that foreground star has a planet, the planet can create a tiny extra signal. For a brief moment, gravity reveals what light cannot. That may be how we caught a hint of a planet in Andromeda. But because microlensing events are rare and usually do not repeat, confirming that planet is extremely difficult. So the honest answer is this: Andromeda almost certainly contains planets, but we have not yet built the tools powerful enough to map them directly. And that makes the mystery even more powerful. Somewhere in Andromeda, there may be a planet orbiting a quiet star. On that planet, if life exists, its night sky would look different from ours. The Milky Way might appear as a distant glow, a pale island of light across the cosmic ocean. To them, we would be the faraway galaxy. We would be the mystery. Maybe some civilization in Andromeda has looked toward the Milky Way and asked the same question: is anyone there? But even if life exists in Andromeda, the distance is almost impossible to cross. A radio message traveling at the speed of light would take 2.5 million years to reach it. A reply would take another 2.5 million years to come back. A conversation across that distance would take 5 million years. Civilizations could rise and fall before a single answer returned. That is the scale of the universe. Beautiful, terrifying, silent. And yet, Andromeda is not staying still. The Milky Way and Andromeda are bound by gravity. For years, astronomers have studied their future interaction, and NASA has described Andromeda as moving toward the Milky Way under their mutual gravitational pull. One day, the sky of Earth, if Earth still exists, may change forever. Andromeda will grow larger. The faint smudge will become a massive, glowing structure across the night sky. Its spiral arms will stretch from horizon to horizon. Then, over millions and billions of years, the two galaxies may pass through each other. But here is the surprising part. The stars themselves probably will not crash into each other.
Galaxies are mostly empty space. Even when two galaxies collide, individual stars are separated by such enormous distances that they usually pass by safely. But gravity will transform everything.
Stars will be thrown into new orbits. Gas clouds will collide. New stars may be born in brilliant waves. The shape of both galaxies will be changed forever.
And eventually, the Milky Way and Andromeda may become one giant galaxy. Some scientists call this future galaxy Milkomeda, a new cosmic city built from two ancient spirals. But that future is billions of years away. For now, Andromeda remains a distant neighbor, a reminder that the universe is larger than our ancestors imagined, a reminder that every small blur of light may hide something enormous. A reminder that discovery often begins with something that looks ordinary, a little cloud, a faint glow, a mystery in the dark.
Andromeda teaches us humility, because when we look at it, we are not just looking at a galaxy. We are looking at the moment humanity realized the Milky Way was not alone.
We are looking at 1 trillion stars. We are looking at possible worlds we may never reach. We are looking into the past. And maybe, in some strange way, we are also looking into the future. Because Andromeda is coming, not tomorrow, not in our lifetime, not even in the lifetime of our species, unless we survive far beyond anything we know today. But on the clock of the universe, it is already on its way.
So the next time you stand beneath a dark sky, find the constellation Andromeda. Look for that faint blur, that soft glow, that tiny patch of light that seems almost too weak to matter.
And remember what it really is. A galaxy, a trillion suns, a graveyard of ancient collisions, a birthplace of new stars, a possible home to countless planets, and the future companion of our own Milky Way. The universe does not reveal its greatest secrets loudly. Sometimes it hides them in a small cloud of light, waiting for someone to look closer.
And that is the power of science. It takes the faintest glow in the sky and turns it into a doorway to the infinite.
This is infinite science. Keep looking up because the next great discovery may already be shining above you.